to Maths with Bob. Today we're looking at coordinate geometry again and finding equations of lines which given by certain conditions. You can see sometimes you're actually given the line like this one. You can actually see the line goes through 8 on the y-axis and 6 on the x-axis. We're just asked to find its equation. Well, the first thing we can see straight away is that we have a y-intercept 8, okay, and we know from the y equals mx plus b that the b is the y-intercept. So what we would say is, okay, the line must look like y equals mx plus 8. And the only unknown is the m in this case, which is great, okay, so we just have to find the slope. Now, this is where a few people get a bit confused. Now, if you look at the rise, okay, it is 8, and the run, okay, a quick look here, is in fact 6. So what a lot of people do is they write, okay, m is equal to 8 over 6, now, or 4/3. Now, there's something obviously wrong with this, obviously, because you can see straight away that the line has a negative slope. So you need to actually add the negative sign if you're doing it this way. Now, people actually can avoid that by going out 6 and down. So it's actually, instead of a rise, it's a fall of 8, so they write it as minus 8. But the net result of the geometry is then that this slope is in fact equal to negative, need to put that in, 4 on 3. So the equation of the line would be y equals minus 4 on 3 x plus 8. So that's the equation of the line, okay? So let's write it in. Y equals minus 4 on 3 x plus 8. This is the line going through 8 and 6. So sometimes you're asked to write this in general form. So in general form, okay, you can multiply everything by 3 to clear the fractions. 3y equals minus 4x plus now 3/8, so 24. And you put everything on the left-hand side, make it equal to 0. Write the x term first, make sure it's positive, adjust if necessary. So write that as 4x now plus 3y. Now the 24 is going over as well, so it's minus 24 equals 0. Okay. Well, that's the equation of the line in general form. Okay, let's look at the next situation. The next situation is we actually have a line already, 6x minus 5. We're told to find the equation of the line through A, which is at 5, 2, and it has to be parallel. So the first thing we need to know is parallel lines. Okay, well obviously the slope must be the same if it's parallel. So straight away we know the equation must be y is equal to, okay, 6x, got to be parallel, same slope, because we know y equals mx plus b, the 6 in front of the x, or the coefficient of the x in that line is its slope. And the only thing we need to find is the b. So this is a pretty easy one. All we need to do is substitute the point A, which is 5, 2, into here. So x is 5 and y is 2, therefore 2 is equal to, now 5 6s are 30, plus b, okay, therefore b you can see here is minus 28. Therefore, the equation of the line, y equals 6x minus 28. Okay, this is the line. So this line here, this is the line here. Okay, y equals 6x minus 28. It's going through A. Okay, that wasn't too bad. Let's look at the next case. Now, the next case is a bit about perpendicular lines. So we've got a line y equals 3x minus 11 already. We've got a point A somewhere, 3, 4. We want the equation of the line through that point A, but it has to be perpendicular to that other line, y equals 3x minus 11. So the first thing we need to look at is what is perpendicular lines? What is the relationship between the gradients? Okay. Well, hopefully we remember it's m1 times m2 equals negative 1. So we know that this line which we're after here, this is the line here we're after, would have a slope of, let's see, the gradient is 3, so it's 3 times what is negative 1. Hopefully we know it's the negative 1/3. So we know that the equation of the line would look like y equals minus 1/3 x plus b. Now, how did I get that minus 1/3? Well, 3 times minus 1/3 is negative 1, or some people say, look, okay, the gradient is 3. It's the line perpendicular to it must have a gradient of negative reciprocal of 3, which is negative 1/3. So we know that's the situation, and we know that, again, it goes through A, that we can sub in the x and the y from the A. So the y is 4 equals minus 1/3 the x, which is 3. That's handy, that'll cancel, plus b, so we just cancel the 3's, 1, 1, and then we know that's negative 1. Put it on the other side, therefore b equals 5. That's not too bad. So straight away we know the line is y is equal to what? Let's have a look. Negative 1/3 x plus 5. Okay, so let's write that in. Where is that line? This line is this one here. Y equals minus 1/3 x plus 5. Okay, so that was not too bad. I mean, we could write that in general form. Let's actually do it in general form as well while we're here. In general form, just first of all clear the fractions, multiply by 3. We'd get something like 3y equals minus x. Now plus, now we have to multiply that 5 by 3. It'll be 15. And let's move it all over in general form. Therefore, it'll be x plus 3y minus 15 equals 0. So that'll be the equation of the line in general form. Okay. Now let's look at the next situation. This is a bit more advanced. But here I have two lines. And this is a situation where I want to find the equation of a line through the intersection of two other lines. The intersection obviously is here. And we don't know what its coordinates are. We could find its coordinates by solving the two lines simultaneously and finding its coordinates. But there is something called the lambda technique, or the K method sometimes, or the lambda method, which basically allows you to find the equations of lines through the intersection of two other lines without finding the intersection point, which is pretty amazing. So what you normally have is you have basically some line. Let's call that line 3. And you'd actually have to find, say it could be parallel to that line. You might need to find that through A, or it actually could be, say, it's perpendicular to that particular line. So the situation is you need to use this little formula. Now there's a little formula which says that the equation of a line through the intersection of two other lines is this one, L1 plus lambda, or KL2 equals 0. Now, when we use this formula, we basically are after the lambda value for which, in which case, or the conditions satisfy that lambda value. So for instance, if it was parallel to another line, I'd need to try and get the gradient in terms of lambda and equate it to the gradient of the other line. Now if it was perpendicular to a particular line through the intersection of those two lines, then I'd try and obviously get the gradient in terms of lambda, and then equate it to the negative reciprocal of the line. So I'll just draw that up quickly. What would that be? That would be like, I'd have a line here, call that line 3, and I want the equation of the line through the intersection of those two lines, but it'd have to be perpendicular to that original line. So you can see this is quite a sophisticated little formula, and I'm just going to leave it here for today, but I will do some examples on this method called the lambda method later. Thank you for watching. Bye.